welcome to Ron. How are you? I tell you what, I think we're all, because we're all using Zoom so much nowadays, we're all getting fairly good at being able to spot the real from the virtual background.
Well, I'm actually one of the early investors in Zoom.
Oh, okay.
So every time we do a Zoom conference, I just smile.
and something in your mind just goes ka-ching.
Yes. I've been all over your website, and I feel like I'm home because what Melbourne Angels does and what the Band of Angels does are so close, both operationally and culturally. I could attend a meeting of yours and probably not notice any cultural difference.
Yes. No. Well, that's Jordan. I mean, Jordan's very, very strong on collaboration running through everything
I've known
he
him
does.
for years. I'm a big fan.
Yeah.
The only area we differ in is, unfortunately, our valuations are probably 3 times yours, not by choice, but just because of the crazy stupidity of California.
This is your pre-money valuations.
Right.
Yeah.
If we could get deals in the $2 to $3 million range, we'd be thrilled. Typically, the California is the highest valued area in the country then there's Boston, which is almost as high. I'm with the Angel Capital Association. We're just finishing our annual report on what valuations we've paid by region, and I was asked to comment on the charts, and the chart that has California, is very high valuation. I said, well, the text should be California investors are stupid. My favorite story about that is one of our colleagues started a company. We liked him. He's a great guy. And he came to us for investment a year later. And I looked at his numbers and I said, you are twice as high as you should be based on revenue multiples. And he said, well, I promised my first round investors a 2x step up. And I said, well, why do we care about that? And he could raise money from no investor in Northern California. Right?
Yep. So you guys got a 2x step up, and that's as far as you're going. Right.
So I don't care what your last round was. That doesn't, it's not relevant to where you are right now in your business. Guess what percentage of deals in the U.S. angel investors did on a safe note last year, 2019? 20%? 40%?
That's crazy.
And again, no, I'm asking. Guess. Pick a number.
10.
1.4%.
Fantastic.
Of all, I won't even look at one. I'll consider a post-money safe, the new kind, in extremis. But I keep telling you, the investor, the angel, the entrepreneur, we have to have a deal that's fair to both sides. And this is so egregiously unfair that we have plenty of deal flow. We don't need this.
Yes,
It's a pleasure to be with you today. And Jordan, I was just telling your colleagues that that Melbourne Angels and the Band of Angels, my group, are so similar. I could probably walk into one of your meetings, and not do anything terribly egregiously wrong. Our operating principles are virtually identical, and what we invest is virtually identical.
Well, thank you for saying that. It's something I'm often telling people.
Here we go.
So,
this feels like popcorn. You wait a minute or so, and when the corn stops popping, you open the lid, but the dings of the participants are the time interval is getting longer and longer. So I think it's almost popped.
So welcome everybody to our Melbourne Angels at Noon session. I'd just like to introduce, for those of you who are guests, I'd like to introduce you to Melbourne Angels. So we're a collective of private individuals who work together to invest in startups. We're investing our own money, not as a fund, but directly out of our own pockets. And we do it on a regular basis. We couldn't do what we do without the support of these organizations who provide us with assistance and guidance and support. And to give you a bit of an idea, we are the most active startup investors, certainly in Victoria, and one of the most active in the country. We typically do in excess of 20 transactions a year, in the order of about $3 million a year. We have over 85 members and over 75 companies in the portfolio. And this year, because of the pandemic, we've actually doubled the number of meetings. So we're actually meeting twice a month in most months this year to accommodate the deal flow. So anybody who's telling you that startup investing has slowed down or become difficult during the pandemic is probably not engaged in the angel space. For us, it's actually been quite busy. In fact, this year, in the first quarter this year, we've already invested more than a third of what we invested last year. So we're doing even more. And these are just some of the stats of what it means to have been active with Melbourne Angels over the last dozen or so years. And we did have our most recent exit was just late last year with Rome to Rio that we were very proud of. And most people hopefully will have heard of that company and know that it continues to be a great Australian success story. So I'd certainly welcome you all to think about joining Melbourne Angels. We're always looking for new members. The more we have, the more we can do, the more different people we have, the better we can make our decisions. Today, I want to point out that we've got a session in which it's not only our regular Angels at Noon session, we also have formed a special interest group into artificial intelligence. And that team are people who have brought us together today with this particular topic. And we do this now every month, of course, as we have for over a dozen years. So I'd certainly encourage you to plan to be with us next month. Now, I'd just like to take a moment to go ahead and introduce our speaker today. Our speaker is Ron Weissman. Ron is based in Silicon Valley in California. He's been there for most of his life, and he's studied at the University of Berkeley. And for those of you who follow the computer world, early in his career, Ron was a senior staffer at Next Computer, and he's gone on to have a variety of interesting roles. And then he moved into the world of venture capital about 20 years ago and joined one of the major venture capital firms, and then also shortly thereafter moved into the Band of Angels, which is one of the premium angel groups in the United States, and a good partner that Melbourne Angels talks to on a regular basis. Ron's a friend of mine, and one of the things Ron's been doing for the last few years is helping people understand how to invest in artificial intelligence, both as a core business and as an adjunct to a business that you're making use of artificial intelligence. And it's obviously not a homogenous topic. So with that, I'm going to hand over to Ron, and we'll hear what Ron has to say. Ron, over to you.
Well, listen, thank you very much, Jordan, for that gracious introduction. I've known Jordan for many years. We're both very involved in international angel groups. In that regard, I want to say that the Angel Capital Association is having a fall set of meetings end of this month. You're all invited to it. And much of the focus is on international collaboration, international syndication, what's new. So check out the Angel Capital Association website for more information. If anybody needs some help, certainly reach out to me. So I'm going into screen sharing mode right now. And let's see. All right. Can you all see can you all see this video?
Yes.
All right.
I have a long-standing relationship with death. Almost 30 years. I in life always believe the desire to survive and the fear of death were artistic sentiments. I understand that better now. But there is one thing that makes me different. I do not believe in my death. Do you?
Now we'll talk about what this is all about in 1 minute. Launch my major presentation here. That was Salvador Dali, who died in 1989. And what you see is a complete reconstruction of Dali done by the Dali Museum in Florida. It is entirely based on AI. It is a completely synthetic Salvador Dali who answers questions, who deals with in 3 different workstations of full-sized images of Dali 2.5D that you can interact with. He'll take your picture, and it's all synthetic. Based on voice recordings, based on images that have been synthetically reconstructed. He is a 2.5D living avatar. And that's very much where AI is going. One of the most interesting examples I've seen. We're going to talk today is all the bad stuff going on in AI, where almost every piece of software today is called AI. We'll learn about zombies, digital alchemy, why a club sandwich is important, how we get rid of all the lawyers, and what's up with killer robots. So the frontier of AI, just some of the more radical things going on is we've had our first AI constructed painting sold by Christie's for $432,000 about a year ago. Zoolingua, which is experimenting in animal-human communications. Can we decipher animal speech? The bottom left, 2 newscasters, very much in the Salvador Dali mode, who are entirely synthetic, who read the news in China every evening. Lots of work on brain computer interfaces, including by Elon Musk. And for people who say AI is just BS, there's nothing important going on, at the top right is probably the most important AI experiment of our day, and that is PizzaGan, where an AI has learned how to cook a pizza by looking at various images. So if you think AI is not solving important problems, check out PizzaGan. Our agenda, let's look at the big picture, the age of deep learning. Let's look at some hot sectors. Let's look at the perennial question is, are we facing AI winter again? What's coming? And what's up with joining or investing in a company in 2020 in AI? So when we talk about AI, we mean artificial intelligence is software that performs complex tasks of learning and cognition at a level that matches or exceeds that of human beings. The most important area of AI right now are deep learning and machine learning, which I'll explain shortly. But very important branches also include robotics, computer vision, and this thing called AGI, artificial general intelligence. And that is an AI that can operate in the world in any context, in any question, can move from healthcare to architecture in one fluid move. And that AGI does not exist. And it's a long way away from existing. That's what the general public thinks that AI is general intelligence. We are not there yet. We're making great strides in specific kinds of intelligence. AI is very old. It goes back to Alan Turing in the 1940s. The real birth of AI took place at a Dartmouth conference in '56, where the term AI was coined. And even back then, we had 2 primary models of AI. One was a model trying to mimic the human brain using neural computation, and the other was logic-based, if-then logic. You know, if you're running a fever and you have a cough and you've been to China, you probably have COVID-19, that kind of rule-based logic. Rule-based logic in expert systems dominated the 60s and the 70s, and it wasn't until 1982 that we had a rebirth of neural computing, trying to use connection models to mimic the brain. But deep learning exploded in 2012. In 2006, one of the Turing Award winners from last year, Jeff Hinton, made a profound alteration to the neural net model. What he simply did was he fed the errors back into the network and say, what's wrong? Can we become self-correcting? Why did the network make a mistake? And his students in 2012 put this kind of AI on the map when one of the best competitions annually is ImageNet to classify images automatically. His students won with a margin of distance between the next competitor of at least 25%. So deep learning was on the map, and from 2012 on, the funding and the interest in deep learning exploded. 2016, Google won the Go competition with AlphaGo. All of this has been powered by NVIDIA GPUs. And where we are today is the era of applied deep learning in robotics, auto tech, healthcare, commerce. And if you look at all the AI dollars out there, 70% are being spent in China. Well, that's really where we are right now. Deep learning is the fastest growing part of AI. It's about 175% increasing in terms of its funding, its patents. It's $156 billion overall this year. Machine learning, which is the basic part of deep learning, is going to be 130 billion just within the next 5 years. So this is an exploding market. Global funding for AI, and you can see how things exploded in 2014, 2015, where we are in 2019. $34 billion in mergers and acquisition, $37 billion in simple investment, $5 billion in IPOs. So the total number of companies funded really from 2013-14 on, about 11,000 AI companies exist in the world, and 150 billion has already been funded. So for those of us who are investors, these should be staggering numbers. With 11,000 companies funded, that doesn't include the unfunded companies, and $150 billion going in, we have to be very worried about the competitive landscape and the extent to which the big buyers, who we'll talk about momentarily, already have made their bets. So this is not a greenfield market. It's not a new market at all. Billions have been spent. AI has begun to fall a little bit in terms of the number of deals. The number of deals fell in Q1. This was like every other sector, from semiconductors to software to medtech, when deal dollars in Q1 and Q2 went later stage. Safer, less concerned with volatility because of COVID. I don't know if this is a temporary phenomenon or a permanent one, but what happened in AI mirrors virtually every other sector of investing. But for all the money going into AI from folks like us, three times that money is going in because of the tech giants. They're outspending us. We are a relatively small percentage of overall AI funding. Corporations are leading the way here. Since 2010, we've had 635 acquisitions, and what's being acquired? Companies in healthcare, media, retail, transportation and logistics, cybersecurity, data management, some platform technologies like speech, NLP, and computer vision. But recently, by and large, what's been acquired is applied AI. Up until 2017, 2018, it was all platform technology, but the game is now shifted to technologies that are solving business problems. So just to summarize global trends, 150 billion invested, 32 acorns, 11,000 companies. And if you look at who's doing the acquisitions, it's the FANG group, it's Google, it's Apple, it's Facebook, it's Amazon. The vast majority of companies acquired are by those 5 or 6 companies. 6% of all AI companies, active companies, have been acquired, and 70% of that in the past 3 years. The average Exit's been $500 million, but there's some multi-billion-dollar acquisitions that skew that. The median exit's been about 195 million US, and the average multiple at exit's about 6.6x. So this is the current dynamic of the AI market. So looking in 2020, where are we? We've got 150 billion. COVID is both a spur to markets like healthcare, but it's also causing existing markets to move a bit later stage. Corporate investing is outstripping all other investing. We're probably at the peak right now of machine learning, deep learning hype cycle. Valuations are strong. There is significant room for innovation, but look in new sectors. Look in areas that are not saturated with companies. That's one of my pieces of advice. This chart shows what's hot and what will be emerging. What's hot today, what's in mass demand: facial recognition, computing at the edge, that is segmenting computing between back-end servers and small devices, IoT at the edge, medical imaging, e-commerce, predictive maintenance. These are all areas that are very saturated and full of startups and full of more mature companies. So what's hot? Well, let's first talk a little bit about how AI works and look at unsupervised deep learning. One example of this is the company Neon, which is an experiment by Samsung to create digital avatars. These were introduced at one of the main commercial shows this year in January. Within 4 years, there'll be a toolkit where any business can create, online physicians, online tech support, online police, even online models. That's Samsung's vision, very much like the Salvador Dali. But let's look at what's going on with AI. There is a distinction between supervised and unsupervised learning. The way AI works is you build a model, and you build the model by labeling data and looking at what the correlations are between various features of that data and what you're trying to predict. So you would put in 100,000 images of cats and dogs, and the neural net model would train itself using labeled data. This is a cat, this is a dog, and figuring out what the differences were. 90% of the solution with traditional AI is doing that kind of labeling at $10 an item. We'll talk about ways to invest in data labeling a little bit later. You then build and validate a net, and then you test that network by looking at unclassified objects to see how well you did, and you do, as Jeff Hinton did, force the errors back into the model to correct the model. This is a lot of work. It's very expensive. It takes a long time to label data, and the models are data dependent. The hottest trend right now is unsupervised machine learning, where common characteristics are discovered being techniques like k-means clustering, where you're not using training data, you're letting the data speak for itself and trying to figure out what the differences are based on statistical techniques. So you can manage things you've never seen before. If you've never seen a woman crossing the street, tripping in the street, dropping her groceries, and you're building a system for autonomous vehicles, that use case will not be in the system's vocabulary. Using unsupervised machine learning with companies like Cortica in Israel are trying to figure out situations that have not been pre-programmed via existing neural nets, using unsupervised machine learning on a broader spectrum of data. So you can manage a broader spectrum of unanticipated super situations, and you can also do an initial job of labeling without people. So some of the cooler projects I've seen are Wandelbots in Germany, where a supervisor puts on a coat, moves around, and trains a robot by moving in natural space. Or Mindtrace, a UK company which is focusing on one problem, which is how to detect pedestrians walking in irregular, unexpected, unanticipated ways, like jaywalking. And none of these technologies, whether it's DataVisor or Cortica, require labeled data. They're all experimenting with unstructured, unsupervised machine learning. XAI. XAI stands for explainable AI, or as insiders say, we're going to move from the black box, which is we don't know how neural nets operate. They operate statistically based on continuous weighting of variables, to the glass box, which is open and observable. Why do we need to do this? Well, the European Union in 2018 said that any algorithm that touches a human being gives the human being a right to an explanation. Why was I denied a heart transplant? Why was I denied a loan? Why did that commander in the field shell an innocent village? Why was I approved for insurance but at a much higher premium than I expected? Why did that autonomous car crash? So the EU says that by 2019, 2020, any AI that touches a human needs to be explainable. New York City has passed the Algorithmic Accountability Act, and there's a lot of work going on in making AI explainable. MIT, Microsoft, and a great company called H2O are all trying to build open source tools that anyone can embed in an AI so these neural nets can explain themselves. So one of the key questions you should be asking any investable company that touches humans is, do you have XAI? Can you explain how the neural net reached a conclusion touching a human being? Sense making. Another term for this is situational awareness. It's a term that comes from the intelligence community. What is going on around me? What do I need to be aware of before I take action, or as I plan to take action? So Maersk has partnered with a company called Sea Machines to look at what's happening at sea, particularly as Maersk vehicles, container ships, approach a port, where you have dozens to hundreds of vehicles. You've got weather to worry about. You've got communications to worry about, some of which breaks down. What's happening? I want to be safe in my approach to the port. The same thing is going on with the Canadian Air Force, with LabForge. When a fighter pilot is up in the air, LabForge is detecting what's going on around that fighter and informing, using alerts, what danger might be that's not necessarily visible. For people like us, Iris wants to know what's going on inside the car. Is the driver being distracted by noisy children? Is the driver drinking? What's happening that might create risk factors, and to then link this to control and to warning systems? MIT is probably doing the scariest thing, which is what's going on inside of other cars around you. Based on the behavior of drivers in other cars, and based on what we've seen across hundreds of thousands of other cases, is the behavior of that driver, is he likely to cut in front of us and make an illegal left-hand turn? Is he the kind of aggressive driver who might cut us off? So can we use predictive analytics based on this kind of AI to improve the safety of our car based on what's happening around us? Some people think this is quite scary, a little bit too far in terms of personal security. A second kind of sense making is not about situational awareness, it's detecting human emotion states. Lots of interesting projects here. Affectiva is looking at driver behavior to predict safe behavior. Beyond Verbal is looking at emotional states via the voice as another part of health screening. Deployed now in some theaters in the US is Crowd Emotion, where sensors are tracking our faces, checking our audience reactions to content. Did we like this teaser? Did we like this first run movie? What's our reaction? And then Kairos is doing the same thing, but it also can scan us and segment us by age, gender, and ethnicity and say, hey, young black males love this movie, older white women hated it. In Arizona, it's now admissible as evidence to use eye motion and as a lie detector in Arizona courts. So you can see some of the radical uses of AI effective computing to detect emotional states. And this is only the beginning of what's going on. From tools to verticals. Well, there's been an explosion in vertical market AI really since the start of this of the neural net revolution. Really began to speed up in 2016, 2017. It is now cheaper and much more commercially doable, at least on some of the hardware and software fronts. We have specialized AI processors like NVIDIA's GPU, which have really won the hearts of most investors. We have big data consortia to collect big data across industries like in automotive. We have cheap IoT sensors that are pennies a piece, so we can widely deploy sensors. And we have free software we can deploy. Now, I'm going to explain in a few minutes why that's not quite enough, but this is at least enabling an explosion of experimentation at the corporate level. So let's first look at healthcare. The robot will see you now. AI is actively being used in disease detection, diagnosis, classification, matching treatments. We're looking at using AI to triage admissions, particularly after accidents. We have to deal with lots of people, matching people in clinical trials who are more likely to finish the trial. In the US, there are 16,000 clinical trials a year, and a staggeringly large number fail to complete as people drop out or disqualify themselves by their behavior during the clinical trials. We can better match those trials. We have a higher completion rate. We can test in silico the potential dangers of a new drug even before it's created. We can automate the boring task of doctor's visits, documentation by AI transcriptions and coding of patient records. We can review bills. Blockchain is widely used to store and share patient records. Hospitals are using predictive analytics to look at patient risk. And by patient risk, what kinds of patients are going to not follow the protocol and potentially, particularly for government reimbursement, deny us our reimbursement when patients behave in ways that disqualify hospitals. For example, readmitting a patient with pneumonia within 30 days. That in the US, that eliminates government reimbursement. What's the risk analysis in a population for things like COVID, and lots of work in robotics for surgery and to make nurses safer by automating some of the nurse-patient contact. So here are some of the results we've been seeing in the past couple of years across a broad variety of modalities. Stanford has shown that AI can diagnose skin cancers better than MDs. In Australia, there's a much more nuanced diagnosis of bipolar disorder and depression by the combination of the Data 61 unit in CSIRO. Brain tumors, 87% accurate diagnosis compared to 66% for MDs in China. Diabetic blindness, diagnosed in 20 seconds, not in hours. Lung cancer, 33% more accurate than with physicians, and so forth. Many of these are research experiments. Few of them have made it into standard medical practice, but you can see where the world is going. And that's why healthcare is the #1 spend on AI right now. AI funding, $900 million invested in Q1. In diagnostics alone across all of 2019, 1.7 billion, which is going to grow to 32 billion within 7 years from now. So you can see that this is an exploding market growing at more than 50%. And we've had some great outcomes. Flatiron Health, electronic medical record, was acquired 2 years ago for about $2 billion. So healthcare funding remains strong. A number of interesting startups you can read here for yourself. Babylon Health in the UK has more than 1,000 staff who are focusing more on programming AI than anything else, doing health assessment across dozens of modalities. They've just raised a $500 million round. At the top right, you see Maybu, which is a personal health companion that takes the vital signs of people, allowing nurses to avoid that kind of dangerous work. A number of these technologies have been licensed for use. Sugar IQ has been licensed with Medtronics to use IBM's Watson AI. Arteris has a radiology assistant for lung and liver tumor diagnosis. It's been approved by the U.S. Federal Drug Administration. My favorite here is Silex, which is an Armenian company that has a national electronic medical record plus genomic screening to do real population analytics for Armenia and soon for Kazakhstan. One of my personal investments is a Canadian company called Cyclica, which predicts the toxic effects of drugs for companies like Bayer, all in silico, in computer, well before a drug has ever been physically formulated. So the world we're moving in healthcare is this kind of world where AI is used to intake the patient's history in an ambulance or at home, and to collect vitals and status, sent to an automated nurse who does patient scanning, AI triage upon admission, creating an initial care plan and initial assessment, all stored in the today's ubiquitous electronic medical records. A lot of tools for physicians to help with diagnosis, and in healthcare today, the terminology right now is hybrid or collaborative AI, where doctors plus AI work together, where it's not AI by itself, but it's that collaborative work. We transcribe notes on these encounters. We use natural language processing to extract what we've learned. That is then fed back into AI systems with more data points for better analytics. We match clinical trials. We build treatment plans. At the end of the day, we have care bots. We have automated systems to manage and monitor care plans and manage and predict drug adherence, and smart devices at patients' homes. Each of these technologies exists today. They've not been combined into a complete whole, but there are any number of experiments doing that. This means faster diagnosis, better outcomes, single view of the patient, and so forth. McKinsey said, what's all this mean? $300 billion of savings simply from machine learning, population health forecasting. That was before COVID. 3.3 billion in the UK from better preventative care. For all of us, between 3 months and 1.3 years of increased life expectancy with the technology we have now, if it's appropriately deployed. What about COVID? Well, understanding the disease, we've got experiments going on in Mayo Clinic using text analysis against 8 million clinical notes to try to figure out symptoms we didn't realize were COVID symptoms. Screening, Providence St. Joseph Hospital triaged, and when it was first launched, 40,000 patients a week. The University of South Florida has 90% accuracy now in detecting and distinguishing COVID from influenza. Palantir, the company went public this week, that's really a CIA securities-based company, is also active in healthcare. It tracks terrorists, and it also now tracks COVID patients. So it's being used for behavioral tracking. In New York University, machine learning is predicting which patients are going to need a hospital bed for asset allocation. But the warning is that clinical decision-making requires big data. These are experiments. We still need to be humble. We have not found regular mass deployment yet. We're moving in that direction, but this is all good news, and it shows where we're heading. But be aware of inaccuracy and bias in data. We'll be getting to that right now. So a question that's now being asked, this AI all sounds really good, but is it healthy? Does it work? So the National Academy of Medicine in December of last year issued a report saying that of the 32,000 apps that are on the App Store for Apple or Google, many of which are AI powered, that claim to improve health, there's been no validation. Most AI models are tested in computer, not in real world clinical settings, where clinical settings are messy, where there are time constraints, where people can misread computers and so forth, where you can introduce error. So most of these AI models that I presented in the previous page were tested in perfect controlled environments, not in the wild. Almost no AI companies submit their research to peer-reviewed journals, and there's been very, very little in the way of randomized clinical trials. So as Gartner says, medical AI is at the peak of inflated expectations. And as I like to say, Silicon Valley's stupid phrase, fail fast and fix it later, is not an accepted medical protocol. So the point here is there's great work being done in AI, but we need to make sure we deploy it carefully under more controlled situations, under more real world scenarios, and to make sure there's been some validation. Real estate, lots of great stuff going on in real estate, matching buyers with properties that they might like, finding comparable houses to the one you like via computer vision, identifying properties that you should invest in or buy because they have the highest chance of cash flow or eventual sale. Good analytics to help bidders bid better on properties, particularly for large commercial properties. Automatic contract review to find errors and omissions in real estate contracts. Blockchain is being used around the world from Nigeria to Sweden to simplify transactions and to hopefully put the title insurance business out of business. Site selection is being done with AI. Chatbots are being used as the first point of contact when a client calls a realtor, and lots of work in predictive maintenance for large commercial buildings. So here are some of the hot companies that have received funding for real estate: virtual agents, Chatbox, used by the largest realtor in the US, Remax, Home Search with Realtor.com, where you upload a photograph of a house you like, and the system then suggests other houses for you. Propertunity, which says, why don't you buy that house as opposed to the one down the street? It's going to appreciate in price much faster. Or Inodo Score, which says, okay, you own an apartment building or a house, and you want to attract the right buyers. What do you need to do to make that house maximally attractive? Is replacing the carpets really the best thing? What about the lighting sconces? Might that give you a better price increase based on our database of what's happened in the past? A fun experiment happened about a year ago, comparing whether an AI or an experienced broker could best predict which house a buyer might like. So in Denver, a real buyer selected a house, but he didn't say why he liked it. And 3 brokers and 1 bot were asked to pick and rank 6 houses for that buyer. The bot beat the broker in every test, guessing the best property for the buyer, even when the buyer did not say why he liked that house. Realtors, your days are numbered. So about the slowest profession, I hope I'm not insulting any lawyers. I only have 2 venture lawyers in my family, and frequently do insult them. But this is not a fast-moving field traditionally in terms of new technology. Richard Susskind, OBE, wrote a book, well-regarded book in '96, where he predicted in the future that clients would communicate via email. And that comment was considered the most shocking part of his book, that shocked lawyers. Why would we ever do business over email? So we've got lawyer bots. We have automatic detection of conflicts of interest before you take a case. A lot of machine learning for e-discovery, for document redaction, contract review. Great analytics for predicting the value of a case, predicting the case outcomes and case expenses, and of course, for profiling not just jurors, but judges. And lots of routine task automation. Well, Shakespeare said, first kill all the lawyers. Now, the current mantra is replace them with bots. So a kid in the UK, is 15 years old, wrote something called Do Not Pay. It was a chatbot. And as of last year, this chatbot had overturned $9.3 million in traffic fines and had voided 375,000 tickets. In the middle of 2019, he launched 1,000 new bots for things like adjudicating maternity leave, landlord-tenant disputes, asylum. He's now a junior at Stanford University. So chatbots powered by AI are able to do some pretty amazing things. Some of the interesting recent investments in digital lawyering. Blue Jay in Canada predicting tax and employment case outcomes. Ross in Canada as well is reducing the need for legal assistance by about a third. Auto in the UK is automating legal and paralegal work, and it's automating about 23% what lawyers do, but 2/3 what paralegals do. Case lines, it takes a whole body of evidence and tries to structure it into a logical form, a timeline that is better able to be managed, and where facets of the case that were not clear can be revealed. So this is what's happening in the law. Again, my favorite real-world example is what happened when LawGeeks, a contract review software, was compared with 20 experienced lawyers. Now, in the room today with all of us, we all know about non-disclosure agreements. Well, the task was to read a bunch of non-disclosure agreements and find problems, badly written NDAs that expose one side or another side to risks that we didn't anticipate and we never would agree on. So the AI found 94% of those risks. Experienced lawyers who happened to be law school professors at places like Stanford University found 85% of the risks. The lawyers took 92 minutes per document to find those 85%. AI took 94% of the risks in 26 seconds across all 5 documents. What's this mean for legal fees? Well, this is my computation. 1,000 times faster. So if you want these 5 or 6 NDAs reviewed, it'll cost you $3.80 coming to the Ron Weissman AI law firm. You can pay my daughter $3,800 if you'd rather use a real lawyer. So broadly based, what are the use cases that are gaining popularity? Automotive, autonomous cars, driver safety system, and financial services, authentication, portfolio management, which is another word for the robo-advisors, healthcare, both diagnostics as well as preventative medicine, preventative screening. The biggest in tech is certainly network security, which has exploded. Second biggest market after healthcare is retail, and it's all being used to sell you and I more stuff based on more knowledge about us, vast quantities of data used to do pinpoint personalization. In industrial, it's predictive maintenance and lots going on in smart buildings around energy efficiency. As I've said, projecting revenue distributions going forward, it's health and sales and marketing where are the dominant sectors and expected to be the dominant sectors. Let's look at another opportunity areas that are ripe for investing. So if we're going to use machine learning, and I should define some terms here, one of my slides was inadvertently left out. Machine learning is using big data to build a model of behavior to predict the future using big data. Deep learning is a subclass of machine learning, where deep learning uses many machine learning layers. So in deep learning, you might have one layer that identifies the color of an object, another layer that looks at the shape, another looks at the texture, another one says, okay, combining those, am I looking at hair or fur? Others which look at the shape of the animal, others which look for abnormalities. So you may have layers, dozens of layers. That kind of machine learning is called deep learning, and it's often compared to a club sandwich or lasagna, where each layer in the lasagna is performing a separate task, all combined to weight and score the objects you're trying to classify or identify or work with in some way. So what this requires is a massive amount of in-house or third-party acquired data, millions or billions of observations. We need the data ecosystems. We need data engineers to prepare the data, and we need data scientists to build the algorithm. These are the things we need if corporations are going to be building their own AI. So it's just one example here of what's going on. This is automotive, where automotive consortia as well as third-party data providers and service bureaus are collecting all of this data. Data on the connected driver, who's driving, how's the driver doing, is that driver issuing safety alerts, maintenance alerts, recall, what's going on with the engine, with the trip log, and these are all going into massive repositories that will be usable for automotive AI. Companies like Winelli and Verizon are helping build these vast repositories to which automotive companies can subscribe. One of the main obstacles to AI is a worldwide talent shortage. This is an IBM chart that looks at the number of postings for AI in 2015 and says, what's that going to look like in 2020? What's the average time to fill these, and what's the average salary? So for folks like data scientists, we need 61,000 of them. For data analysts, data system developers, the people who prep the data, we're going to need close to 1 million of them. We don't have nearly that much talent. Canada produces 1/10 across all of Canada the number of AI people needed to fill Toronto's current demand. And there are over 44,000 job listings in the US today requiring machine learning, about 100,000 worldwide. So a survey of corporate execs said the single largest adoption issues for Americans are staff skills and the quality of staff. Same thing in Europe. Data science and engineering, the scientists who build our models, the data engineers who build our data. In Western Europe, these were the single largest obstacles and skill gaps, not just for AI, but for the organization as a whole, and duplicate mirroring here in Eastern Europe. But the good news is we've got some great companies and which was still some great investment opportunities. First, data engineering, tools to help us prep the data, make the data usable much more quickly, identify errors, identify outliers, clean the data. Biggest, most expensive problem is data labeling. And there are a number of companies like Playment, like Labelbox, like Super Annotate in Armenia, like Appen in the US, that are all tools that do some of the automated work of labeling. There are data exchanges with companies like Ocean and Mighty AI, where you can sell the data you've created in the public market for other companies to buy, or you can exchange data. Some of these are data exchanges, and there are companies that are trying to figure out if synthetic data, artificially created data, can be used to build models. There's crowdsourced data, companies like Kaggle and Factual, or data science as a service, and particularly in Africa, there are whole villages of women who are employed as data labelers by a brilliant company called Samasource, which is doing data labeling in Africa for small companies like Google and Microsoft, and bringing a real financial lifeline and good training to women in dozens and dozens of villages in Nigeria and Kenya, both something that's doing good and something that's doing well. So these are all areas where there's no declared winner yet. They're ripe for innovation, but this is solving the big data problem. Something that's happening worldwide, and it's happening particularly, I believe, here in Australia, is what I call insight as a service. If you look at the history of computation, we've always started out, even in the 50s, with raw algorithms, which then are turned into programs like Fortran or COBOL, or today Python. Those evolve into platforms, complete systems for managing the development process, right now in movements around things like DevOps, VMware, and so forth. Vertical solutions, where you have companies like Oracle bringing complete solutions in areas like software validation in healthcare or basic accounting services. So beyond that, people say, look, I don't want to do any of this. I can't afford to hire data scientists. I can't afford to curate big data. I know I need AI. My competitors are using it. So I want insight as a service. I don't want to do any of this. I want a consulting company to come in. There are dozens of consulting companies, including your own Sentient, which, while not using the term insight as a service, they're going to come in and do your AI for you. They're going to find you data, going to help you analyze that data, and then finally going to provide you with finished intelligence, which is basically, tell me how to improve my business. I don't care about the technologies you use. Just tell me, using the best data you can and the best AI models, what I should do to improve my business. So a company I've worked with for the past couple of years doing this is a company called eLinks, which is doing predictive analytics as a service. And the problem they're solving is that fluctuations in oil prices require optimized production. So you get the lowest production cost per barrel, particularly in today's economy where you have to force people, you have to pay them to take a barrel of oil. So what the company has done is it has measured 40,000 oil wells and has created some models for different kinds of oil wells called digital twins, which is the word used in machine learning whenever you're building a digital equivalent of a real world phenomenon. It might be a model of the inner ear. It could be an oil well. It could be an air conditioning system. And what they offer is analytics as a service where they will come in and tell you which lever to push, how to adjust the pressure or temperature of a pump to improve production. And they're already seeing things like 6% improved production with radically lowered production costs. So is it AI winter again? Well, let's beware of the hype. The UK did a study for the House of Lords last year that said that 40% of AI startups in Europe used no AI. And simply labeling yourself as an AI company attracts more than 15% more funding from folks like us. Back in 2013, there were only 50 new startups having anything to do with AI. Now 1 in 12 says they're AI-based at the heart of their value proposition. As one scientist, as Professor Julio Amador said, there are 26 million software developments in the world, but only 300,000 people with real AI skills. So we're now labeling everything that used to be, old-fashioned business intelligence as AI. Everything now has AI. MIT thinks that 2/3 of all software companies and software products are now AI, labeled as AI. So be careful. We've had a long history of AI hype. It's not new. Simon and Newell said in 1958, within 10 years, a digital computer will be the world's chess champion. Or Marvin Minsky in 1970, in 3 to 8 years, we'll have general intelligence. Or Marvin Minsky, again, within a generation, the problem of creating AI will be solved, he said in 1967. Andrew Ng, the guy responsible for Google Brain and the AI and Baidu, AI is the new electricity. And the CEO of Google, AI is more profound than electricity. Well, we've had lots of failures in the AI world. We've had issues of data bias. We've had Watson doing cancer, therapeutics, issuing therapeutic recommendations that would actually kill a patient. So IBM pulled out of that market. Facebook had 2 chatbots create a private language, which scared the heck out of Facebook, and they shut the project down. Apple was sued for false arrest for $1 billion for a facial recognition error. On the right here, you see some names of some of products when an AI was asked to create names for colors based on existing colors. And Light of the Blast, Grassbat, Sindus Poop, again, a spectacular failure. A Sentient, not related to the Australian Sentient, but a US hedge fund, collapsed entirely as its hedge fund analytics based on AI simply did not work. So what AI winter has been, new technology, for example, new ways of doing medical computing using if-then logic, rule-based computing in the 60s and 70s, a whole new way of hope and hype. Compute power caught up, so we now can process those models. Investors poured much money in, being seduced by the promise. There were some applications that did do some good work, like Mycin at Stanford. But if you looked overall, very few AIs did very much, and people began to question all the investment, and startups were crushed. So between 1974 and 1980, you could not attract dollars into AI. 1987 to 93, same thing. And not much was going on before 2011, 2012. And these periods are called AI winters. So the question for us is, are we beyond all of this? Have we escaped AI winter? Well, some people don't think so. Basically think that, yes, we can build great AI, and the promise of AI is real, but the problem with AI is that 5 or 6 or 10 companies in the world can really do it. They have the budget, they have the server power, they have the talent, and they have the tens of billions of objects of big data. So while many companies are trying it, they're not going to succeed because their models aren't really in depth enough, and they don't have the right kind of real data science on board. And that's the fear. So we're already saying as well, do we need to look at other paths? Are there other things we need to worry about besides deep learning? So some of the best minds in the field, like some of Hinton's colleagues, are now saying, let's look in other areas beyond deep learning. So what's next? So there are some big problems in AI that are all very investable. First is we need efficient AI. The number of calculations to be considered a breakthrough model, one that's beating all the others, grew not by 300, but by 300,000-fold between 2019 2013. The computing scale needed for AI has been doubling every 2 years between 2005 and 2011. Now it's been growing at a factor of 7x per year. Just think about that. It's at this asymptotic rate. Facebook has the best natural language processing model in the world. It has maxed out that model at 500 NVIDIA GPU boards, and all it can process is 250,000 words. 2 million is what it needs to be considered comprehensively accurate. And training that model took 3 times the annual energy of an American. This is not just sustainable. So that's one problem. Second is, where's the science in data science? Right now, we are still at an experimental discipline. We can't explain it. 2 research teams using similar data, not identical, but similar data at different places in the world can't reproduce the same model's output. We can't trace where our data came from. We can't validate our data, that it's accurate, that it's free of bias, that it's not based mostly on middle-aged men as opposed to women or whites rather than ethnic minorities. There are no standards for data collection and data validation. There are no quality standards for validating AI models. So as I say, where's the science? There's lots of good work at universities that can be commercialized in each of these areas, but turning AI from an engineering discipline into a science is one of the great investable challenges of the next generation. We also need to do better deep learning, as deep learning requires massive data, football field-sized server farms, and that's what Apple has been buying. It's been buying massive property in North Carolina to build these gigantic server farms. Deep learning only solves 80% of the problem that is identifiable by the objects that you're modeling with your labeling process. It doesn't solve the unlabeled problem. It can't respond to things it's never seen, and it has no memory. It can't remember what it did before. So if it found a solution to something, there's no way to store the solution to that. If it built a previous model that's good for X, it's really hard to recall that during an operative active AI. And AI knows nothing about cause and effect. It only knows correlations. It doesn't know causation. So the 7th generation, generation 7, is going to be focusing, and this is my view of the world, overcoming AI limits. First is moving from massively scaled AI to efficient AI. And a word for this is red AI, which is a resource-intensive AI, versus green AI, which is resource-responsible AI. Think of it as eco-AI. Lots of research and using quantum computing to power deep learning. So we have, as I said, these deep learning models that are dozens or hundreds of layers deep. Quantum computing can allow us to have deep learning models that are hundreds of thousands or millions of layers deep. We've got better chip design coming, designed specifically to power AI. Research is going on now for what's called sparse data models. Data models that don't require you to fill up every cell in an AI model. You don't need necessarily billions of data points, billions of data elements to build that model. Same thing with synthetic data, ways in which you can create data that is good enough without having to label it. And there's been work, it's called transformer-based natural language processing models, which is the fancy way of saying we used to do natural language by looking at each word in a sentence and then looking at the word that followed it. Today, transformer-based models allow us to look at every word simultaneously, radically speeding the work of natural language processing models and making this much, much more real time. Second area, bringing the science back to data science, going from trial and error to science and doing things like figuring out which model is best for solving which problem and creating essentially meta models that will say we've got 1,000 models we know of, let's pick the right one for insurance rating in this community. Ethical AI, making sure that data exchanges are not infringing on privacy and are really true to a population being studied. They lack bias, and building those governance models where we can do validation and we can do XAI. New foundations, lots of experiments and lots of companies now working on AI at the edge. What can we put AI into machine sensors so we don't have to send the data back, back across the network? We can look at, for example, intrusion detection and have enough pattern recognition to say this particular behavior of this person at my security door is a kind of behavior I've never seen before. There's something anomalous. Let me check this out further. Can we transfer learning from one AI to another? Can we go from pattern recognition to why? And perhaps the most exciting practical thing that's happening right now, which should be super obvious, but is marrying rule-based symbolic AI, those if-then models, with neural models into more comprehensive work. Where this is happening right now at the most extensive is autonomous driving. The newer models combine both neural and symbolic. So let's look at joining an AI company, funding an AI company, or investing in an AI company. I'm sure you've seen things like this before. When I evaluate a deal, and it's a larger deal with real diligence, I look at the business model. I ask myself, am I excited by the vision? Does it fit my profile in terms of deal size and geography? Is the deal terms right in terms of the kind of term sheet, valuation, preferences, my investor rights? Am I going to achieve my returns target based on my analysis of outcomes? Am I as an angel going to get at least 10 to 30x? Are the risks acceptable? Can I deal with these kinds of risks? And can I do facts, confirm those facts and hypotheses by my diligence about markets, competitors? So this is just good practice. Those of you who have not been exposed to this kind of anal diligence, this is what at least some of us who are more anally inclined try to do. Most importantly, we try to take the 5 or 10 most important bullets off this chart for this particular company. And these things need to be applied to any company. AI does not make something magical. The average funding needed to reach mergers and acquisitions, and 90% of all exits are via M&A, is $27 million US. So your startup is going to need more money than we can provide. And what's the larger capital requirements mean for us? Well, we've got cram down risks. We've got standing at the bottom of a big liquidation preference. We've got pay to play. If a company is in trouble and can't raise money and a noble knight comes to the table, but either crams us down or puts a play to play in work. We've got VCs who claim they invest but are really spraying and praying in a dozen companies who may never back the company again. We've got opportunities with Series A and B. I never look a gift horse in the mouth. I always take some of my money off the table if somebody wants to buy my shares at Series A or Series B, as has happened in a couple of occasions. Will later round VCs protect us? By Series D, they probably don't even remember who the angel investors were and don't really even know us personally. Are they going to protect us? Who's the follow-on investor who has not placed their AI bets if they're a strategic? So for me, diligence is just as much about business and capital, about who's going to come next, and what are the exit opportunities, as they are about the algorithm or the product, because it's capital risks that may sink some of these companies, particularly if they have a bad economy or a bad patch. My evaluation checklist is the team world-class? Did they graduate from the best universities? Are they truly world-class scientists capable of doing breakthrough work? Is this real AI? Or more likely, is it reheated business intelligence? Is this deep learning? Is it rule-based? And you don't need to understand the algorithm to understand at least what approach they're taking. Is it based on deep learning? If so, what kind of model are they building? What does the model predict? If it's rule-based, what are some of the rules? What's the logic of the system? Again, you don't need to be an AI scientist to ask those questions. If it's in a vertical market, was it designed with a vertical market partner? Or my least favorite answer, oh no, Ron, my CTO went to Stanford. He's really smart. That's how we knew what to build. Well, if it's a vertical market solution, it better be done with a vertical market partner. Are you solving a real problem, or is this a science project? Many developers in young companies would rather solve hard problems than problems that pay the rent. And I saw this with a company I'm thinking of investing in yesterday. They're solving problems at the edge of AI rather than problems that customers will pay for. So is this an algorithm or is it a company? Are they targeting mainstream customers, or are they targeting just the usual suspects of tech companies, universities, and government labs? What about regulatory issues? Can they detect bias in their data, and can they explain what they do? Where are they going to get enough data? What's their plan for acquiring the billions of items they may need? What's it going to cost to scale computationally? And what's the capital requirements for companies like this? And for me, the cynical question, yeah, but don't investors and doesn't Apple and Google already have something like this? And are we facing an acqui-hire risk? I don't know about Australia, but I do know about the US, where AI, many companies are being acquired for their talent. Those are acqui-hires. And the amount of money that's being paid for the talent is great for the talent, but it's marginal for us because they're not paying for IP, they're not paying for product, they're not paying for customer base or book of business, they're simply paying for talent. So for us, a $100 million deal becomes a $10 million deal with promises of great dividends for the staff who've been acquired. So is there a risk of acqui-hire? And finally, most importantly, do we have customer validated, game-changing, best-in-class results? So conclusion, where are we today? Lots of AI, lots of M&A, but M&A is expensive. Many acqui-hires. The FANG companies are major competitors, not just buyers, and there are major competitors. We don't just think of the competitive landscape as other companies like ours, because Google, Amazon, Facebook, Netflix are all building technologies and sometimes licensing those technologies or open sourcing those technologies in markets where we think we have proprietary software. But there are plenty of opportunities, and we've moved from platforms now to vertical markets, and exploring some of those new models to challenge the deep learning hegemony of Apple and Facebook and Google, using some of those techniques I mentioned earlier, like investing in companies that are trying to make it so we don't need so much big data. Just remember, many investors and acquirers have already made their bets. Understand where your company fits in. So guidance, look for markets not populated by Me Too's. The buyer and the sponsor should move beyond the hype to ask tough questions about AI quality and ethics and and the costs and risks of AI. Are you solving an early adopter problem or a mainstream problem? Early adopters buy tools and they'll buy one of anything, but mainstream buyers want to solve a business problem. Someone on your team better know that vertical market in their bones. So build use cases and validate results by partnering with real customers. So again, does this company deliver significantly better outcomes than other AIs, and do the results matter? So thank you for listening. I'd be glad to take questions at this point.
Thanks very much, Ron. That's been great. So we will take questions. If you want to ask questions, please raise the little blue hand in Zoom, and we'll go from there. First off, I know that Duncan has a question he'd like to ask.
So I'll answer Robert Veste's question. As I said in the presentation, I think that the market is very bright. And I think that right now AI is well beyond the capabilities of even companies who think they can do it. They just can't hire the talent, acquire the data, put the pieces together. So I think that the future is really, really bright for whatever you want to call it, insight as a service, AI as a service. Remember, what you're providing is finished intelligence, and you're hiding all of the AI stuff from your customer. What they want to know is, tell me what to do, not what to build.
Ron, my question was, invariably when the subject of AI in the medtech space comes up is what are the insurance companies going to do, you know, if they get their hands on the data? So are you seeing in startup land in AIs, are they embracing talking with the insurance industry, or are they actively working to sideline them?
I had a few dozen other markets. In other presentations I've talked about things like logistics, things like insurance. I know the insurance market pretty well. I've run an insurance startup in the past. My dad helped invent the modern model of health insurance. He was one of the founders of what's called Kaiser in the U.S. So I've kind of raised with insurance. Insurance which is a laggard market, is now really embracing AI for automated underwriting, for doing claims analytics, for doing things like fraud detection, which is super big in some markets. So yes, companies like the Hartford and others are quite embracing AI. And there's always an arms race between providers and payers. I think so we've had bill review for years in the US because of our insurance model paying for healthcare. So what's going on in the US historically has been that medical groups would pad their bills with lots of things, and they would figure out which codes to use that are most likely to get reimbursed. And then insurance companies would have trained nurses look at those bills and using some BI software to look at obvious problems, things that were never in the contract, and so forth and so on. All of that kind of arms warfare is going to go to AI. So I think that there'll be a lot of collaboration, but there's going to be a lot of use of AI by insurers to deny payers, providers bills, and a lot of use by providers to figure out clever ways to bill that won't be rejected.
Thank you.
That's my cynical view of the world.
Great. Next, we'll have a question from Srikanth.
Oh, thanks, Ron. So we have been doing a bit of AI for quite a few years, but still I had an opportunity to learn a lot. Thanks for that. So I have several questions. So in your opinion, when do you think the AI will become self-aware?
When will AI become self-aware? I don't have a clue. The first question is, what is self-aware? So right now, AI lacks a memory. AI lacks any notion of causality. There's some basic epistemological problems that AI needs to solve first. So you first need to give AI a memory, right? So there is a project between the Stanford Research Institute and the US Defense Department to try to figure out how to give AI a memory. So that's one major step. They haven't solved it yet, but they're working on that problem. Secondly, AI needs to have some notion of causality, so it can build models much better. It has some notion of intentionality. It has to have some notion where it can select its own goals from a whole field of goals. Might that happen in 5 years? Sure. Is Elon Musk crazy for being scared? No, not at all. Bill Gates thinks he's crazy on multiple dimensions. So what do you think? You're an AI guy. What do you think about self-awareness?
I think it is, in my opinion, it is inevitable. It is just a matter of time. The question is how much time? Is it, like I said, 5 years, 10 years, 20 years? But my bet is on 10 years or between 10 to 15 years.
So for you, what's the big breakthrough that we need? What are the conceptual breakthroughs that self-aware AI would need?
So I think it is these models that we are talking about, this trained and self-trained models. I think that is what will lead to that. This self-learning is what is going to be causing or helping that journey. So the more we help the possibility of self-learning and make it happen. Sorry, that's what I mean.
Yeah. So one of the other things we're going to need is, what you're saying is that AI is synonymous with AGI, artificial general intelligence, because to be self-aware, you need to ask the question, where am I? What am I doing? What am I looking at in an unbounded way? Right? What's going on around me?
Okay, so we'll take the next question.
Thank you for the next question.
Sorry, Shrikant, but we'll move on. We'll take the next question from David Bennett.
Thank you. I thought I knew a little about AI. I've had to revise my opinion. I've been just blown away by the amount and depth of knowledge out there on the subject of where AI is up to and how to invest in it. I do trust that the presentation we've just seen will be available, because I think I've got a lot of reading to do.
I'll make one little modification. I'm going to give you the full presentation. I've left out some slides. I'll give you the whole thing.
That's wonderful.
That doesn't include all the vertical markets. They're scattered through too many presentations, but you'll get the longer version of tonight's presentation.
So my question is, have you heard of a company called Numenta? And if not, if you have, are they part of the leading edge? And if not, where is the leading edge?
So yes, I've heard of Numenta, but remind me what they do.
Oh, this is
so many companies. What's
this Numenta? Is a time model of learning. This is a neural model which learns sequences.
Oh yes. Which
goes to your comments about memory a little while ago. Learning sequences is a critically important part of general AI.
Absolutely, and it absolutely, yes, and it's you can't do things. You can't create a logical order if you don't know anything about sequencing. So, and this is particularly important in any AI which is going to generate a workflow, a recipe, a care plan. You need to be able to do things like that. So yes.
What about driving a car?
Yeah. Right. So, what was the second part of your question?
Oh, that's it. Where is the leading edge? Where is a potentially investable, but the leading edge? Where are things happening?
Well, so one of the areas that's very exciting is in brain machine interfaces, and that's going to be used in lots and lots of different ways, not just in areas like healthcare, but for potentially transferring information. If you ever saw the TV show The Dollhouse, where they were uploading people's brains, having brain computer interfaces is a 1% first step, but the amount of money going into that and the number of smart people working on brain human interfaces for training, for healthcare, for guidance is staggering. I don't think we even begun to understand what that portends. So for me, really breaking the boundary between neural computing and the human brain is right up there with the most radical things I know about.
Great.
And there's no leader. There's no leader out there.
By the way, is that a real background or are those your books?
What's that?
Is that a real background, or are those, no, that's a background, not your book?
So it's a real background. I'm a former academic, and I have a very, very large library. And I took a photo of part of my library to use as a background photo, no matter where I'm giving this talk from, so you don't see my messy office. But it's all real.
Great.
Excellent. So we've got two more questions, and then we'll probably have to call it a day. First, Hugo Richard.
Hi, Ron. Thanks for the presentation. So we're an AI company, and I've got a question. You've mentioned obviously that data labeling and is quite expensive, and that today model requires a large amount of data. I'm not sure if you're aware, but I got a question, which is, do you think that over time model will require less and less data? For example, when a kid learns how to walk, it's sort of a one-shot learning. And specifically with the emergence of what's called single-shot learning, and maybe the work that Google is doing with what's called AutoML. I don't know if you're familiar with those two, but what do you think about this? Because it feels like now ML is becoming much more available for anyone. There is TensorFlow.js. We can do model directly in the browser using JavaScript. Don't you think that model moving forward will require less data?
I am totally with you there. I had a section of this presentation on AutoML. What AutoML is, it basically it avoids many of the intermediary tasks between collecting data on the one end and building a model or outputting a model on the other. Companies, a lot of work going on at MIT, a lot of work going on at Google with AutoML, with Microsoft, with AutoML projects, which is a fancy way of saying we can do things like select the best model from a family of models, so you don't have to build it yourself. Where model creation, model selection is automated for you, and what you focus on is inputs and outputs. So not ready for prime time now, but I expect in a year or two there are going to be a number of companies doing exactly this. It's going to migrate from Google and MIT into the real world. So yeah.
Okay, I've got just one more follow-up question, because we've built an algorithm that can assess the likelihood of someone having dyslexia, which is a learning disorder. Where would you classify us? Would we be health tech or edutech?
I would classify. I always classify things based on who the customer is.
Yeah.
Right. So, but one more thing, Hugo. One more thing I would suggest is when we start having validated models, approved models, we're going to see systems built on combining those models. We'll have, this is already happening in autonomous driving, where you have many model subsystems to help pilot a car, some of which are well understood, some of which are experimental. And as those models become hardened and validated, we're going to have Tinker Toy Lego systems. There'll always be room for innovation and improvement. But once we can start trusting our models, I think that we'll be able to buy models off the shelf or rent them SaaS-like to create kind of super systems. So the world of Lego and the world of AI will but we need to do the boring stuff first: validation, trust, things of that sort.
Yeah, I agree.
And our last question from Paul Boxer.
Well, I was going to do a David Bennett and ask 5 questions. If limit, stick to 1. Interested in the right of explanation that's came up a couple of years ago in Europe. There are a lot of systems out there that it's extremely difficult to be able to give an explanation why it occurred. I'd like to just understand a little bit more about what are the consequences of having an AI system out there make some sort of decision and being unable to explain it. And is there any sort of grandfathering of older systems?
I took a look at Australian what Australia is thinking about on one of your regulatory websites, or one of the there is a whole discussion of ethical and liability issues in AI, and you guys have done a better job of raising the issues than most other places have. So at least according to what I've read, your regulatory authority has realized that there is a liability issue if AI makes a mistake. And they're trying to figure out how to assign liability. Right now, they're saying initially the creator of the AI bears the brunt of that responsibility. In California, courts are also holding the same thing. But that is one of these frontier issues that is where the technology is moving decades faster than the regulatory authority. But that's the whole point of XAI. You need to be explained. You can't do it unless you can explain it, because if something wrong happens, we'd understand what happened, why it happened, and maybe how to remedy it.
But there are plenty of companies out there producing systems that can't explain their decisions. So how do you handle those? That's
right. So, but in Europe, this is going to be a mandatory, not an optional, but a mandatory. Okay. It's certainly going to be grounds for litigation. If somebody denies you something based on an AI they can't explain, you can say this was arbitrary and capricious behavior. Just like if you're if the guy next to you is promoted, he's done the same work you have, and you're denied a promotion, and you ask, why aren't I being promoted? Because we're not going to tell you, right? That's in the U.S. That's actionable.
Yeah, I can understand that situation, but wouldn't that reduce the amount of AI development in Europe and America because of fear of that litigation?
It should, but that's a temporary thing, because you can still be doing AI development and then working with a Google or a Microsoft or an MIT to embed the explanatory layer. I think that XAI is going to be a temporary problem. There is so much focused on it. So, but you should be asking your investee companies, what's your strategy for getting there? We realize you don't have it today. Do you realize it's a problem, and how are you going to deal with it?
Okay, thank you.
Excellent. Well, I'm sure there's a lot more we could say, but we do have to call the session to a close. So if everybody would join me in thanking Ron for making his time available this evening, his time.
Much. Ron,
and I would love to. I'd love to go a revisited presentation in person. After when the world starts again. So all of you stay safe.
We'd love to have you. So thank you, everybody, and keep an eye out for Angels at Noon at the end of this month. Hope you all have a great weekend. Take care.
Thank you, everyone. That was wonderful. Cheers.
Thank you. Thank you very much.
Bye-bye.
Thank you.